Let's start with today's featured paper, Fantastic Pretraining Optimizers and Where to Find Them Too. Hyperball Optimization by Kaiwe Won and Percy Leong from Stanford University. Here's a full breakdown. Contribution 1. Hyperball Optimizer Wrapper. Hyperball is a simple optimizer wrapper that achieves 20 to 30% token equivalent speedup over weight decay baselines on Qwen 3 style models up to 1.2b parameters when combined with muon. It operates by setting the Frobenius norms of weight matrices and their corresponding optimizer updates to fixed constants, replacing the implicit norm control of decoupled weight decay. This method maintains the efficiency gains of matrix-based optimizers at higher compute and improves learning rate transfer across widths and depths compared to decoupled weight decay. Contribution 2. Stabilizing matrix optimizer speedups. The paper addresses the issue where speedups of matrix-based optimizers like muon shrink from roughly 30% to about 10% as model size and data scale grow. Hyperball, as an optimizer wrapper, explicitly enforces constant weight norms and update norms, contrasting with the implicit norm control of standard decoupled weight decay. This explicit norm control allows matrix-based optimizers to maintain significant efficiency gains, specifically 20 to 30% token equivalent speedup for larger models and datasets. Contribution 3. Theoretical basis for norm control. Hyperball is motivated by prior theory indicating that training with weight decay establishes an equilibrium weight norm solely dependent on training hyperparameters. Standard decoupled weight decay implicitly controls the norm via the 1 eta t lambda WT term, which shrinks weights, thereby deciding the angular learning rate or how the weight matrix direction changes. Explicitly fixing Frobenius norms of weights and updates offers a more direct and stable control mechanism than implicit weight decay, particularly beneficial for scale-invariant layers in modern transformers, leading to improved learning rate transferability. That was our featured paper. Today, ArXiv received 1,867 new computer science papers across 46 subfields. Let's look at the research landscape before we continue with the remaining papers. The AI landscape today is dominated by advancements in LLMs and multimodal systems, alongside a growing focus on green AI. Let's dive into the papers that made the cut. Get this, we can now run advanced AI design processes directly on tiny embedded devices, even those with under 512 megabytes of RAM. And we're seeing LLM agents tackle incredibly complex, multi-agent economic simulations, pushing the boundaries of AI autonomy. Now let's explore each of today's trends in detail, starting with number 1. Trend 1 of 10, Advanced Algorithmic and Stability Analysis. This trend develops advanced algorithms and rigorous analytical methods to ensure stability, efficiency, and optimal performance in complex systems and computations. This cluster covers 185 papers. Representative work includes compositional small gain and small phase stability analysis, divide into noise, a game-theoretic method for fairly composing diffusion models, and avoiding exponential blowup in distributive lattice submodular minimization. Trend 2 of 10, Efficient Vision Transformer Architectures. This cluster covers 184 papers. Representative work includes VigilFormer, deformable attention for video anomaly detection with causal risk inference, BBRNet, boundary-balanced replay for continual medical image segmentation, and steady forcing, balancing spatial persistence and motion continuity in long-horizon nature video diffusion. Trend 3 of 10, LLM Systems and Applications. Focuses on building, optimizing, and applying large language models in diverse systems and real-world scenarios. This cluster covers 153 papers. Representative work includes Swarm LLM, collaborative inference for edge-based small language models, Scribby, a multi-level LLM framework for semantic video analysis, and unified KV pooling to accelerate long-context LLM serving. Trend 4 of 10, Learning and Optimization for Diverse Tasks. This trend explores applying learning and optimization methods to solve diverse tasks efficiently and effectively. This cluster covers 191 papers. Representative work includes recurring public transit schedules, stable identification from GTFS and similarity analysis, disagreement-based cross-model routing for implicit video question answering, and interpolation between convolution and attention via k-nearest neighbors. Trend 5 of 10, Edge AI and Domain Applications. Applying AI, often on edge devices, to solve real-world problems across diverse specialized domains. This cluster covers 152 papers. Representative work includes RAMs, Resource Adaptive and Detection Condition Model Switching for Embedded Edge Perception, AI for Maritime Security. Comparative Evaluation of CNN and Vision Transformer Architectures for Maritime Object Detection. And FairGen, Preference-Aligned Diffusion for Demographically Equitable Medical Image Synthesis. Trend 6 of 10, Multimodal Data Analysis and Architectures. Integrating and analyzing diverse data types through specialized architectures for comprehensive insights. This cluster covers 190 papers. Representative work includes secure and low-latency IoT analytics using an edge-based streaming architecture, hierarchical GRU with input condition slot queries for ball action anticipation, and schema-agnostic process trace construction, from raw tables to execution behavior. Trend 7 of 10, Social Systems, Control, and Formal Methods. Investigating social system dynamics and control mechanisms using rigorous formal and computational methodologies. This cluster covers 207 papers. Representative work includes visibility without guidance, measuring the actionability of public crisis communication in Lebanon, obligation-producing actions, and selective control under noisy perception, governance failures hidden by aggregate metrics in modular networks. Trend 8 of 10, AI benchmarking and societal applications. This cluster covers 208 papers. Representative work includes Moreau Bench, benchmarking realism in agentic simulation of real-world discussions, gender differences in AI literacy workshop outcomes and deepfake engagement, and grand challenges for the convergence of computational and citizen science research workshop report. Trend 9 of 10, Green AI and. This trend focuses on developing efficient, sustainable, and resource-aware AI systems and methodologies across diverse applications. This cluster covers 196 papers. Representative work includes Green AI Carbon Optimizer, Carbon-Efficient Training Location Recommendation and Global AI Energy Demand Forecasting, Poster, Edge Citadel, Hybrid NATS MQTT Orchestration for Edge Multi-Agent Systems, and DC Motion, decoupling semantics and details via discrete continuous tokens for human motion generation. Trend 10 of 10, Multimodal AI Evaluation and Challenges. This trend explores methods and frameworks for evaluating multimodal AI models and addressing their inherent challenges. This cluster covers 201 papers. Representative work includes Fuse, quantifying uncertainty in vision language models by Bayesian, fusing epistemic and aleatoric uncertainty, GridVQAX, a framework for evaluating multimodal explainability methods, and HorusEye, language as dynamic attention for emergency visual analysis. That's the full research landscape for today. Remember, our number 1 paper, Fantastic Pretraining Optimizers and Where to Find, was already covered at the top. Now let's continue with papers 2 through 10, one by one. Up next, our second paper out of 10, CoffeeBench, Benchmarking Long Horizon LLM Agents in Heterogeneous Multi-Agent Economies by Issa Sugiura and Takashi Ishida. Let's break down its key contributions. Contribution 1, CoffeeBench Multi-Agent Economy Benchmark. CoffeeBench is introduced as a novel long-horizon multi-agent economy benchmark featuring 6 heterogeneous firms, 2 farmers, 2 roasters, 2 retailers, operating over a 90-day simulation. Agents autonomously manage cash, inventory, and pricing to maximize cumulative net income through communication and transactions, with one roaster controlled by the evaluated LLM and others by fixed reference agents. This benchmark addresses the critical gap of evaluating LLM agents in complex multi-agent economic systems, moving beyond single-agent interactions with passive environments. Contribution 2, LLM Agent Economic Performance. All tested LLM models successfully outperform a passive baseline that takes no actions, with the majority achieving positive net income within the 90-day CoffeeBench simulation. Agents utilize a suite of business tools such as Roast, Make Offer, and Send Message to actively manage their operations and engage in economic transactions. This demonstrates the practical capability of current LLM agents to engage in sustained, goal-oriented economic activity and manage complex business processes over extended periods. Up next, our third paper out of 10, Separable Neural Architectures as Physical World Models, From Mathematical Theory to Applications by Reza T. Batley and Saurav Saha, from Kevin T. Crofton Department of Aerospace and Ocean Engineering, Virginia Polytechnic Institute, and State University. Let's break down its key contributions. Contribution 1, VSNA Theoretical Guarantees. The variational separable neural architecture, VSNA, when viewed as a Galerkin trial space, satisfies classical variational guarantees under Lax-Milgram, including well-posedness, quasi-optimality, convergence, and stability. The SNA combines neural approximation with tensor decomposition, decoupling localized coordinate functions, atoms, from global interactions governed by a sparse, low-rank interaction object. These formal guarantees ensure the mathematical rigor and predictable performance of the VSNA, providing a robust foundation for its application in complex high-dimensional PDE problems. Contribution 2. Algebraic scaling for high-dimensional PDEs. The VSNA mitigates the curse of dimensionality in high-dimensional spatiotemporal, parametric PDEs, scaling algebraically rather than exponentially, with its optimization cost reduced to linear in dimension. This efficiency is achieved by exploiting an entirely factorized, tensor-native alternating least squares, ALS, optimization framework. This significantly overcomes the computational burden of grid-based methods whose degrees of freedom scale exponentially, making previously intractable high-dimensional parametric problems solvable. Up next, our fourth paper out of 10, FraudSMSWalker, benchmarking agentic large language models for SMS-to-Webpage fraud detection by Y.H. Zhou and M. Y. Luo. Let's break down its key contributions. Contribution 1. FraudSMSWalker Benchmark Introduction. A controlled benchmark, FraudSMSWalker, is introduced for URL-masked SMS-to-Webpage fraud judgment, comprising 699 bilingual chains, 332 fraudulent, 367 benign, across 10 service scenarios. The benchmark's model visible input includes SMS context and sanitized web page evidence, while raw URLs, hosts, domains, IPs, redirects, and reputation metadata are explicitly withheld. This design addresses the limitation of prior evaluations that either focus on message-only smishing or allow models to rely on reputation shortcuts, enabling measurement of evidence-grounded fraud judgments. Contribution 2. Agent Performance Evaluation. 9 web agents were evaluated on the FraudSMSWalker benchmark under masked browser agent protocols and URL visibility ablations. The evaluation protocol specifically withheld URL and domain information, forcing agents to rely solely on SMS context and sanitized web page content for fraud judgments. Results indicate that current agents can detect suspicious cues but struggle to preserve benign recall and often produce weakly supported positive predictions. Up next, our fifth paper out of 10, OmniOPSD, Rationale-Privileged On-Policy Self-Distillation for Effective Computing by Zibang Cheng and Qi Tian. Let's break down its key contributions. Contribution 1. OmniOPSD Framework for Effective Computing. OmniOPSD, a rationale-privileged on-policy self-distillation framework, achieves state-of-the-art performance with an average score of 84.19 on Emure UniBench for effective computing. The framework utilizes frontier-generated evidence-aware rationales as training-time privileged evidence context for a local teacher model, which then provides dense token-level supervision to a student model sampling its own rollout. This approach enables the student to learn on its own trajectory distribution without directly imitating frontier model completions, and crucially, inference requires no labels, rationales, or closed-source model access, overcoming limitations of expensive code annotations and shortcut learning. Contribution 2. Rationale-Privileged Teacher Guidance. OmniOPSD introduces a novel method of using frontier-generated rationales as teacher-side privileged evidence rather than direct student imitation targets. These evidence-aware rationales are exclusively provided as context to a local teacher model during training, which then uses this enhanced understanding to score the student's generated tokens. This mechanism prevents shortcut learning often associated with direct supervised fine-tuning and ensures the student learns to ground decisions in multimodal evidence, providing transparency for safety-critical human-AI interaction without requiring rationales at inference. Up next, our sixth paper out of 10, running hardware-aware neural architecture search on embedded devices under 512 megabytes of RAM by Andrea Mattia Garavagno and Antonio Frisoli from Department of Electrical, Electronic, Telecommunication Engineering and Naval Architecture, Dighton University of Genoa. Let's break down its key contributions. Contribution 1. On-device HWNAS execution. A novel hardware-aware neural architecture search, HWNAS, approach was developed that can execute directly on embedded devices with limited resources, specifically under 512 megabytes of RAM. NAS process explicitly incorporates the resource constraints of the search platform itself, alongside the target deployment hardware, by modifying an existing HWNAS 8. enables on-device model tailoring and adaptation without relying on external servers, significantly enhancing privacy and reducing latency for IoT and edge applications. Contribution 2. Tiny CNNs for MCUs. The proposed HWNAS effectively generates tiny convolutional neural networks, CNNs. CNNs are specifically optimized to operate efficiently on low-end microcontroller units, MCUs, which are characterized by extremely limited computational power and memory, utilizing a search space of fixed-structure cells. Capability extends the reach of deep learning to highly resource-constrained edge devices, facilitating new applications in Internet of Things, IoT, and wearable robotics. Up next, our 7th paper out of 10, UXBench, Measuring the Actionability of LLM-Generated UX Critiques by Wenjie Wang and Xiangliang Zhang from University of Notre Dame. Let's break down its key contributions. Contribution 1. UXBench Interaction-Grounded Benchmark. UXBench is introduced as a benchmark for evaluating LLMs as interaction-grounded UX judges, addressing a gap in measuring critique reliability and actionability. It features local-first runnable web fixtures across 10 product surface families and uses coverage-gated browser exploration to ensure models gather interaction evidence before generating a structured UX report across 7 rubric dimensions. This benchmark provides the first controlled, systematic method to measure the reliability and actionability of LLM-generated UX critiques across diverse interfaces, advancing LLM evaluation in UX. Contribution 2. Automated Repair Lift Protocol. A novel automated repair lift protocol is established to measure the quality of UX critiques by their ability to improve an interface. Report quality is directly quantified by whether a fixed downstream repair agent can successfully improve the interface based on the LLM's critique, effectively measuring critique actionability. This protocol offers an objective and scalable metric for evaluating UX critique utility, moving beyond subjective assessments to directly link critique quality to its tangible impact on interface improvement. Up next, our 8th paper out of 10, DP Hype, Federated Differentially Private Hyperparameter Search by Johannes Liebenow and Esfandiar Mohammadi. Let's break down its key contributions. Contribution 1. Federated Private Hyperparameter Search. DP Hype is a novel algorithm designed for federated and privacy-preserving hyperparameter search in machine learning. It operates by conducting a federated voting process, which aggregates local hyperparameter evaluations from participating clients. This method selects hyperparameters supported by a majority of clients, offering scalability and task agnosticism beyond prior task-specific approaches. Contribution 2. Client-level DP with hyperparameter independence. DP Hype formally proves to preserve client-level differential privacy, a robust privacy guarantee for federated systems. Its privacy guarantees are shown to be independent of the number of hyperparameters evaluated, which is critical for efficient and scalable hyperparameter search. This addresses a key challenge in federated settings by preventing information leakage from aggregated results, leading to a superior privacy utility trade-off. Up next, our 9th paper out of 10, DYNA, Dynamic Episodic Memory Networks for Augmenting Large Language Models with Temporal Knowledge Graphs in Continuous Learning by Ali Sarabadani and Mahtab Tajvidian. Let's break down its key contributions. Contribution 1. Retraining-free LLM augmentation. DYNA, a lightweight framework, augments a frozen LLM with an external temporal knowledge graph to incorporate new knowledge without modification or retraining. Events are represented as nodes, and temporal relations like before, after, and co-occurs are directed, time-stamped edges, forming a continuously updatable memory. When queried, relevant events are retrieved from the graph using random walks and centrality measures to enhance the LLM's output, addressing catastrophic forgetting and costly retraining. Contribution 2. Enhanced temporal recall and forgetting. DYNA achieves a 7% reduction in catastrophic forgetting compared to fine-tuning and a 5% improvement in temporal ordering accuracy over standard RAG on temporal recall tasks. The framework leverages its external temporal knowledge graph to provide contextual temporal information to the LLM, preventing the model from overriding its internal knowledge. These results demonstrate DYNA's ability to significantly enhance continuous learning for LLMs, allowing them to integrate new temporal knowledge efficiently while preserving previously acquired information. Up next, our 10th paper out of 10, Visual Generation in the New Era, an evolution from atomic mapping to agentic world modeling by Qiming Wu and Kaichen Zhang from Tsinghua University. Let's break down its key contributions. Contribution 1. 5-level visual generation taxonomy. A 5-level taxonomy is introduced, categorizing visual generation capabilities from atomic generation to world modeling generation. This framework progresses from passive renderers to interactive, agentic, and world-aware generators, with each level nesting prior capabilities and adding a qualitatively new competence. It provides a capability-centered lens for understanding and advancing the field beyond appearance synthesis, emphasizing the need for structural, temporal, and causal coherence. Contribution 2. Key technical drivers identified. Several key technical drivers are identified as collectively advancing the field towards intelligent visual generation. These drivers include flow matching, unified understanding and generation models, improved visual representations, post-training, reward modeling, data curation, synthetic data distillation, and sampling acceleration. This analysis outlines a shared trajectory for research, fostering the development of controllable, interactive, and physically grounded systems rather than isolated improvements. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.